All right, students, hi, this is Mrs. Foy, and this is a screencast about putting numbers in scientific notation or using exponents. So in chemistry, we have to use really big numbers and really small numbers, and we don't always want to have lots of zeros or really long decimals, and so a lot of times we will put these numbers in scientific notation. So for example, if I were to put the number 10,000 in scientific notation, I see that there's no decimal there, so there's actually only one significant number there, but my imaginary decimal point is right here, so I would move this over 1, 2, 3, 4, and this number becomes 1 times 10 to the 4th, right? Awesome. So, for example, if I had the number 403,000, and this time I have a decimal, that decimal place legitimizes all of those zeros. They're all significant. So I'm going to move my decimal over 1, 2, 3, 4, 5. So this number is going to become times 10 to the 5th, but I have to save all those zeros. So it's going to be 4.03000, right, times 10 to the 5th. Here's another number, 20,130. There's no decimal, so I'm going to have that zero be significant, but not this one. Here is the decimal point, so I'm going to move it over 1, 2, 3, 4. So this is going to be times 10 to the 4th, and my number is going to be 2.013. That zero is not significant, and that's my answer. Sometimes you have a number that is not in correct scientific notation. So for example, 321 times 10 to the minus 3. When you have a number in scientific notation, you're allowed one number to the left of the decimal, and then you're going to put your times 10 and then whatever exponent that you have. So this number is not in correct format. So I need to move it in correct format, and that means I'm going to need to change my decimal, my exponent here. So right here is where the decimal is, right? So I'm going to move that over 1, 2. I need to make this number bigger by 2. You see how I made this number smaller by 2 by a factor of 10 to the 2. That means that if I make this number smaller, I have to make this number bigger. So if I add a 2 here, this is going to make this times 10 to the 1. Okay, so that's my correct answer. So sometimes I'm not just putting big numbers in exponents or in scientific notation. Sometimes I'm putting small numbers in scientific notation. So let's see what it looks like when I have to put small numbers. So this is where I'm going to use negative exponents, right? So if I put 0.0003 in scientific notation, these zeros are just placeholders. So I'm only going to have one sig fig. I'm going to move this over 1, 2, 3. So this is going to be a negative exponent. That means the number is less than 1. That means that number is less than 1. So 0.000405, that zero in between two non-zero numbers is significant. So my answer is going to be 4.05. Let's see how many exponents I need. 1, 2, 3, 4. So this is going to be times 10 to the 4th. So I've got 3 sig figs there. If I use 0.06050, all right, this zero is significant because of the sandwich rule, and that zero is significant because there's a decimal, and I can take a 0 at the very end as significant, but that zero is not. So my number is going to be 6.050, and I had to move this the decimal over 1, 2, so this is going to be times 10 to the minus 2. Okay? So the other thing that I'm going to teach you today is how to multiply and divide using exponents. So the rule with multiplication, if you are multiplying or dividing using scientific notation or using, oops, I didn't spell dividing right, sorry. Using scientific notation or using exponents is that the exponents are going to be added when you multiply, and they are going to be subtracted when you divide. Okay? So, for example, let's look at a problem here. So if I take 3 times 10 to the minus 3 times 2.00 times 10 to the 4. Okay, now I am going to multiply my two numbers here, and I'm going to add my exponents, but I have to be careful about my sig figs. When you do a math problem, you're going to take the least number of sig figs in your answer. So I have 1 sig fig here, and I have 3 sig figs here. But I'm going to take the least, and so my answer is only going to have 1 sig fig. So I'm going to multiply my two numbers here. So 3 times 2 is going to be 6. And then I am going to add my exponents, right? So minus 3 plus 4 is going to be 10 to the 1. So my answer is 6 times 10 to the 1. All right, let's try another one. Let's do this one. Okay, we'll do this in black. Okay, cool. All right, so now let's try 12 times 10 to the 6th divided by 3 times, let's do 3.0, times 10 to the minus 4. All right, so I have 2 sig figs here, right? I have 2 sig figs here, and I have 2 sig figs here. So that means my answer is going to have 2 sig figs. So what I'm going to do is I'm going to divide my two integers. 12 divided by 3 is 4. I'm allowed to have 2 sig figs. And I'm going to subtract my exponents because I'm dividing. So 6 minus a minus 4. Remember your math rules. A minus is actually a plus. So my answer is going to be 10 to the 10. My answer is 4.0 times 10 to the 10 because I have 2 sig figs. So remember that when you multiply numbers with scientific notation, you add the exponents. When you divide, you subtract, but be careful of double negatives becoming positive. And the only other thing you have to remember is that whatever number has the least number of sig figs, that's how many sig figs you'll have in your answer. All right, good luck. Hope this helped. Let's do some practice problems now.